Welcome everyone to today's Nodes Talk. This presentation is brought to you by the University of Manitoba Data Science Nexus within the Faculty of Science. The University of Manitoba campuses are located on the original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dane peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in spirit of reconciliation and collaboration. Today's talk will last approximately 30 minutes. During the talk, a Slido code, which today is V214, will be provided, and you can go and ask questions during the talk. And I'll ask our speaker at that time, or we can also ask our speaker questions at the end of the talk. So do go to slido.com and put your questions. So it's my great pleasure to introduce our speaker, Dave Fulawka. He's the Senior Director, Network Analytics and Development at Bison Transport Incorporated. So let me tell you a bit about Dave. Dave's trucking experience started 30 years ago at the age of 19 in the yard of a Winnipeg, Manitoba company. After earning a bachelor's degree in a Bachelor of Arts degree and a Bachelor of Commerce degree, he started working at Bison Transport in 1994. Dave has been a successful general manager, developing regions, operating divisions, and finding and mentoring talent in that time, and has a reputation for getting things done and developing sustainable operations. In 2013, after leading logistics and intermodal divisions to grow from 38 million to over 100 million in sales in 4 years, Dave was asked to initiate and develop an analytics practice at Bison. Today, a team of 19 people drive the business with deep analytics and predictive analytics. Outside of work, Dave and his wife of 29 years have 4 children. He has invested in his community, both as a coach and director of a local soccer club, coaching over 1,000 games and winning numerous championships and being declared Coach of the Year in 2014. He also leads Eastview Community Church in Winnipeg as a moderator. Very busy member of our community. I'm very grateful Dave accepted my invitation to speak with us. Today, he's going to talk about a graph model that helps reveal information about relationships among the different networks within Bison Transport. He's happy to entertain questions during his talk. So if you have any questions in the middle of his talk, feel free to put it on Slido and I'll ask him right away. I pass it over to you, Dave. Thanks.
Well, thanks a lot, Catherine, and welcome here, everyone. Hoping that this next 30 minutes is you find it interesting and somewhat entertaining. As Catherine said, please don't hesitate to ask questions if you want to. I'm going to cover a lot of ground in this next 30 minutes. I'm going to cover some of it at a high level, going to try to get under the hood and get a little bit of detail in front of you as well, for those of you who are interested in the detail. The foundation of the presentation I'm talking about today is our transition from several relational databases to a graph model, and 2 major projects that basically drove that transition from relational databases to graph model, and the business outcomes that are related to that, some of the successes and failures that we had while working through that stuff, and then also some of the even the visuals that we've established out of that out of those 2 databases. So let me start by just introducing the content that I'll cover, just to introduce our company a little bit, and then I'll talk about the network model, and basically it is a as you'll see in a slide shortly, it's a profit monitor. It also is the foundation of the image of our network on which the pricing engine is built. So basically, it goes a network model, then pricing engine. Those 2 things happen in sequence of each other. And so I'm going to cover a little bit on the pricing engine as well. And please don't hesitate to ask questions as I go along. If something sparks your interest, or if maybe I should repeat something, or just if you want to ask a little more detail about something. We talk a little bit about our company. One highlight here on January 1st. So I've worked for Bison for a very long time. For most of my career, we are owned by one owner, the Jessamine family. And on January 1st, we were acquired by Richardson's. This is exciting. The Richardson is a multi-billion-dollar company, and one of the reasons they acquire companies like ours is because they feel that they need to add that element. So they needed to add a transportation element to their portfolio. And they also have financial resources to help us grow. We've got very aggressive growth targets. You'll see in a couple of slides here that we've grown over time, and they want to support our growth. They have some formal procedures that we're going to have to get used to in terms of being able to justify our plans for growth. But it's very exciting. We have a good partnership that started already, and we look forward to many years of partnership with our new acquiring owner. Let me just talk a little bit about the history of growth. Company started in 1969, a Winnipeg-based company, now has operations in all 48 states and all provinces in Canada. We started then at 10 trucks. In 1994, when I joined, just 92 trucks, and then the rest of the couple of decades after that are history. 1994, if any of you were around back then, major time of transportation deregulation in Manitoba and also in Canada, reverberations in Canada. And that was essentially the reason for our growth, the raison d'etre for our growth. Having said that, the actual growth itself from 500 trucks in 97 to 2,300 trucks in 2020 was a variety of projects and initiatives and successes and satisfied clients that took us through that growth. But today, we're about 2,350 trucks, 6,000 trailers, and about 3,000 employees. So just to get you a sense of the size of our business, Winnipeg-centric, but we've got offices in Toronto, Montreal, in Regina, Saskatoon, Calgary, Edmonton, Vancouver, in Chicago, and in Indianapolis, Des Moines, Grand Forks, North Dakota, and Amherst, Wisconsin. So that's a little bit about us. A little bit about the trucking business, and maybe this gets us essentially sets the table for the conversation about the network model. Typical trucking company margin is about 5%. It's relatively low margin. 45% of our costs are variable costs. Those are things like driver wages and fuel. About 50% of our cost is fixed costs, and so that would be a wide variety of overheads and equipment costs. It's very expensive to manage warehouses, to manage maintenance facilities for our trucks. All those things create a variety of different overheads, but still about 5%. Now, one of the things we've learned over the last 20 years is that as much as typical margins are 5%, if we manage our network very, very well, if we focus the execution of our plans and put high expectations, high standards on ourselves, that there is about a 10% upside on cost management. Of course, we can't manage fuel, and truck drivers are hard to come by. Those people, those 3,000 or so truck drivers we have working for us, are the most important people at our business. Those costs, those variable costs that are paid to drivers, those aren't very easy to manage. It's the other side, the fixed costs. And the simplest example that I can give you is if we were to have one truck only, and that truck drove 10,000 miles. And then that truck drove 11,000 miles, that additional 1,000 miles would essentially reduce the fixed cost by about 10%. And so take that, multiply that by 2,300. That's the kind of math we're talking about here. If we execute well, if we're safe, if we have low claims ratio, if we run efficiently, so we're able to get greater miles, we have about a 10% upside. A little bit about our data, the data side, our overall business here. Sorry about that. So just as I've described, fixed costs are heavy. We have low control over variable costs. A couple more things to highlight here. Things like the exchange rate, things like U.S. or Canadian government policy that might change a flow across the border. These things have a huge impact on our business. And then just to give you a statistic, in any one order, on average, that our business might handle, we handle about 25,000 orders a month. In any one order, there could be as many as 21 people attached to that order. So lots of little details, lots of human inputs, and we spent a lot of time, reflecting back on my comments on efficiency and execution, we found ways to automate many steps and allow the human inputs in our business to spend more time better planning and finding efficiencies than they spend time completing I'll say mundane administrative tasks. So just a little bit on our business, a little bit on the data side. When the average person in our business interfaces with our platform, they have some needs. And some of them are sort of unknown or hidden needs of data governance. They need quality data. They need to be able to trust the data at a very high level. But otherwise, the stuff that's in front of them, they need just the right amount of data. They need just enough to be able to make their decision. Then they need to be able to drill down and get access to summary data if they need to be able to answer questions to say, okay, well, this data point looks like that. Why? Okay, and dig down one more level, and then dig down more level, and we'll talk a little bit about what that looks like. Also, the interface needs to be intuitive. So when we add these few things together, I hope you see these in themes in the presentation I'm about to make and in the visuals that I show. But the average user just, this is a summary of the average user's needs. So let me talk a little bit about the network model. As I said, this precedes the pricing engine. About 10 years ago, we made a decision that our existing operating ratio software would not continue to support our business in the way that it needed. You can see that up until 2000, we were growing pretty rapidly. Our business was widening. The different types of work we were doing was expanding, and so the model itself just simply wasn't sustainable enough, couldn't respond to all of the differences that were there. So to be able to help that model along, we devised a variety of tools. Those tools were overlaid on top of several relational databases, and those relational databases, especially when in the early years, they functioned okay. But what the reason that they sort of the greatest question of sustainability was the fact that our business continued to grow and change. And then we found ourselves doing cross-server joins to be able to move information from two different places and combine it. And those cross-server joins were unstable. The procedures that we wrote were unstable because when two servers are in two different places and they have two different maintenance schedules or whatever, it was very difficult. And so we made a decision to say, okay, well, we're going to have to find a way to take all the critical data points, get them into one model, and be able to establish a network view that would allow us to understand the profitability of our network in any one way. Key elements of that network model are to be able to view subnetworks. So we have the primary whole network, but then we have subnetworks. We have two subsidiaries down in the US. This is the easiest example. Two subsidiaries. Those subsidiaries act as part of our whole network, but they are managed separately as a profit center. And so they have their own customers, they have their own drivers, they have a lot of their own equipment. And so those subnetworks need to be able to be viewed as part of the whole, but as a separate subnetworks. The second thing is we need to be able to understand asset and driver relationships. As I said earlier, fixed costs are so heavy. So to be able to understand how costs and revenues are relating to each other from an asset, so a trailer or tractor perspective, and how particular drivers are contributing to or being over-challenged in terms of contributing to our network. And ultimately, on the right-hand side there, we needed to be able to come up with a universally understood measure of profitability, so that basically it's sort of like a pulse check to be able to understand the health of our business at any one time. A little bit of a history on the graph model. In 2017, we took I'll say a first run at saying we need to transition out of these several relational databases, and one united relational database would have some of its own challenges, that we needed to be able to establish those node and edge relationships in a graph model. And because of a combination of technology and because we simply didn't understand enough about it, I'll say domain knowledge, didn't understand enough about it ourselves, that initial proposal failed. In 2018, especially late in the year, we were able to put a trial graph model together, and that graph model actually succeeded. We were able to get funded to be able to take that graph model up to the next level. The funny part of it was when we went from on a single machine to enterprise-wide with the software that we were using, we found the cost of that software so incredibly high that that initial proposal failed. The really good story at the end of it was that, and we're in a Microsoft environment. Microsoft in a late 2018 update to our server software, our SQL server software, actually allowed us access to a Microsoft Graph database, and that was included in our software update. So we went from, oh my gosh, we can't do this, it's too expensive, to, hey, this is free. And trust me, the Microsoft Graph had some limitations, but we've been able to work within those limitations, and it indeed was the platform for us to be able to move forward. So a little bit about the graph model failure. In the end, it proved to us, when we were ultimately successful in 2018, it proved to us that that graph model was the right thing. So we knew the relational database was not the fit. And obviously, we knew that the graph model was. In the end, the search, the cost, the time, that second failure was just having to find the right one. And in addition to the fact that it's sort of some of the negatives of the Bison graph, or the Microsoft Graph model, some of those limitations were actually completely offset by the fact that all of our relational databases were in a Microsoft environment. And so, using SQL, using programming languages like DAX to overlay, and then access to things like Microsoft Power BI were much easier. And so, even though there were some limitations, there were actually some benefits, unexpected benefits, or realized benefits that somewhat or maybe completely offset all of those limitations. So let me talk a little bit about subnetworks and how the network model works, and understand this. I'm going to give you a very simple example of one round trip. In our network at any one time, there's about 25,000 orders a month. Those 25,000 orders get broken down into order segments because not every driver handles an order from origin to destination. Often an order is picked up by a local driver, or a driver in Western Canada, somewhere in Saskatchewan, brought into Winnipeg. A different driver takes it down to the US. And then that driver unloads the load and reloads the load, and does another move to come back to Canada. Maybe the load they load down in the US is delivered by another city truck, or taken on to somewhere from the place that they leave it. So our network is very complex. Those 25,000 orders break down to, on average, about 60,000 network segments in a month. And the network model that we've built had to be able to have detailed cost and revenue relationships at the segment level. So this is just a graphic example of one round trip, one simple round trip, and the cost and revenue of that round trip. And this is, again, a simple one that has relatively low empty miles, relatively low inefficiency and relatively low leg count. But you can see here that there's a map that helps a person understand what this relationship is. If you fly on to any leg on the map, it'll help you understand the relating customer on that one leg. We can see the operating ratio of the particular driver that did this round trip. And this one happens to be quite profitable. Thankfully, we have ones like this, because we have many that don't work out this way. But in the end, this particular driver went from Winnipeg down to Minnesota, and then went to Rockford, Illinois, and then came back to Winnipeg from there. And the cost and revenue relationships are there. So if I just were to quickly review over this, the network model itself had to be able to get down to the segment of an order cost and revenue relationship to be able to aggregate up to revenue for round trips, and then be able to, and I'll talk later about multiple round trips and within the subnetwork, to be able to aggregate up to any level we can, and all the way up to, in fact, the operating ratio of the entire network. I'm going to take a bit of a step here and describe one more key element of the operation of this network model. It does recognize empty miles. And for a transport company, empty miles are absolutely dead. miles. Typical trucking company like ours runs about 10% empty miles, and so they are a manageable cost, first of all, and they are a cost, a major cost to our business. Just think about that: 10% of our miles are empty. In this particular case, the network model, and let me just describe this. When I said that the network model, that's a really good question, Catherine. So an empty mile is when a truck is pulling a trailer. When they're hauling a customer order, they'll deliver a load, and then once they deliver that load, the trailer's empty, and they'll travel from the place they delivered to the place they're picking up, and in between, they're going to be pulling an empty trailer. So that's a really good question, and hopefully that explains the concept a little bit here. Anyway, so I'll get back to this. So these miles traveled with an empty trailer are a dead cost to our business, and let me just take a step back and talk about the network model again. Somewhere in the neighborhood of 60,000 segments that are costed and revenued every month. There's 100 or so, somewhere north of 100 algorithms that are supporting this network model, and on any one round trip, there could be thousands of possible decisions in the decision tree to assign revenue, cost, or allocations within the confines of that one round trip. So if we think about it that way, about 60,000 segments in a month, if there could be, say, 1,000 choices that are made to be able to cost, revenue, and then match particular segments into a round trip, we're talking about 600,000 decisions a month that are made by the software to be able to give you the image that you're looking at. So anyway, let me get a little bit into under the hood on the empty miles here. In this particular case, excuse me, the driver leaves Winnipeg and he's going to a place just east of Winnipeg called Dryden, Ontario, picking up an order to go down to the US, and between Winnipeg and Dryden, he's running empty. Now, in this particular case, the reason he runs empty from Winnipeg to Dryden is because the customer that he's hauling for is down in Ontario, and so in this particular case, we'll assign the majority of the empty miles on that trip to the customer in Dryden, because otherwise we'd haul out of Winnipeg and have 0 empty miles. So we have that allocation logic built in, and the software itself knows that allocation relationship. It knows that the customer out of Dryden is the reason that those empty miles are occurring. The algorithm logic that we've built understands the revenue relationship and understands what a typical empty trip is. So we move down to North Carolina out of Dryden and have a small empty trip from Shelby, North Carolina to another place in North Carolina where we would load, head out to Nova Scotia, and from there we move into a place in New Brunswick to load that goes back to Wisconsin, and then back to Winnipeg. So that one driver might complete this entire trip with one trailer, may switch trailers along the way, but the logic and the model will sustain that. And within the confines of all of it, the software is smart enough to know that how to allocate the empty miles to a particular trip, so that trip or that segment's operating ratio is accurate, and then also how to allocate it within the confines of this round trip to be able to make sure that the round trip is accurate. Again, the purpose of doing this with such granularity to the very segment of the trip is to allow us to aggregate up from there to a particular region or a particular division or for the whole operation, and be able to say that the operating ratio through all of those cascading levels of granularity would be similar or reliable through all those steps. Just going to get into this a little bit. This is a work of one city driver over 2 hours. And I'm just going to get a little bit deeper into empty mile logic. Within the confines of a city, many drivers pick up and deliver. Oh, sorry about that. I'm just going to look here and say, do the trucks always have to go back to Winnipeg? That's a really good question. The answer is no. So if a driver lives in Ontario, the round trip might start out of Ontario and go back to Ontario. If a driver lives in Calgary or Edmonton, might be the same thing. This example round trip is just because the driver lives in Winnipeg. So in this particular case, this driver would go back to Winnipeg because that's where that person lives. And this trip would take about say 11 or 12 days, might take as many as 2 weeks, depending on some downtime between trips. And so driver goes out for 2 weeks, works really hard, comes home, takes some time off, and then goes back out again. Really good question. So this is just getting another view on empty miles. The complexity of the software can manage all of these relationships within the confines of the Lower Mainland. This is a couple of hours of work for one driver in the Lower Mainland. We have about 50 drivers doing local work in the Lower Mainland, and then we have city operations across Canada. On any one given day, we have 400 trucks doing work. So multiply this, what you're looking at here, by about 1,200 or so per day, 1,200 2 or 3 hour segments per day, and that's the complexity that the software needs to be able to manage. It allocates costs and revenues to these legs according to some very complex logic, and I said relatively resilient algorithms that are able to just relate these things to each other in a way that can make sense out of the costs. So let me just pause there for a minute and see if there are any questions on the network model itself. Again, it's a profit monitor. It assigns costs and revenues. It allows us to image the entire network right down to the segment of an order, but then aggregate up from there. Oh yeah, very good question. So in the end, the colors on this, and I just, I can spend a little more time here. One move, the orange move is a delivery move, and then the purple moves are empty moves. This particular green move is a pickup move, and then this other particular green move is also a pickup move. So driver moves from one place to another loaded. When they unload, they'll sometimes they'll go empty from one place to another, and then they'll load another load. And so the different colors are basically just a representation of the condition of the driver. Is he picking up or delivering an order? And actually, I may have gone backwards there. The orange move is the delivery move, and then there's a pickup move here, and then a move to from one place to another empty, probably with another trailer, and then back to our yard, loading a load here, and back to our yard in the Lower Mainland. Langley is where our yard is in Vancouver. But good question. So getting a little under the hood of the pricing engine, and again, the network model itself is that segment by segment cost and revenue relationship that can be aggregated in various ways. Where the network model is our profit monitor, so it gets us that operating ratio that helps us understand basically the health of our business. The pricing engine is our margin monitor, and so when contract negotiations come up, the engine can provide us with a lot of depth of understanding of what a price should be to be able to either maintain or grow profitability, depending on the angle we're taking with that customer, or with the network that customer fits into, or with the motion in the market at the time. I'm going to get a little technical on the development of this pricing engine. So some concepts here that I want to talk about are centroids, and we're going to talk about clustering and how we find the center of the cluster, and how those cluster centers allow us to simplify the pricing process. I'll talk a little bit about edge definitions and the different ways that we can represent the network based in this graph model to be able to understand different elements or different expectations. And then out of those centroids and edge definitions, those edge and centroid relationships, developed a fundamental pricing equation. And that pricing equation has evolved several times. We're on PE3 right now, and by the end of the year, we'll deliver PE4, which means a fourth generation pricing engine. So we've gone through several different versions or elements of that equation to be able to change weights, or now the weights automatically set themselves based on the data that the circumstances present themselves with. So just move a little bit to understand what it took to get out of the network model, and with a view that we knew we wanted to use all of this network model information to be able to create price. So we went through a complex process to set up a pricing model, and then be able to allow that network model graph information to supply needed data to essentially run the pricing engine. We did a study to identify the optimal number of clusters and the clustering algorithm. Yeah, you know what? I'll show that in a minute. Really good question there. What's being clustered? So I'll answer that in a minute. So we've identified the optimal number of clusters by doing some math. We ran the initial clustering and then had to make some adjustments. Inside, we identified cluster anchors and the necessary edges. And in this case, I'll show you 3 different types of edge. And then we assigned revenue and to the various edges and delivered the MVP. So what's being clustered? What's being clustered here are the origins and destinations of all of the orders that we've had for a year. So this is just that initial representation of the clusters that were created out of the original query to the database out of the network model. The number of clusters here evolves over time. We started with an initial model of 23. In the end, when we delivered the first pricing engine, there was 31, and today there's about 35. So as we've grown our business over time, and also grown the ability of the network model itself and the pricing engine to handle greater granularity, we've actually expanded the number of clusters. So essentially, the geographic origin and destination of orders in our system are the things that are being clustered, to answer that direct question. Once we did deliver the initial output of the clusters, we found anchors on the inside of the cluster against which we could measure, essentially create a rate for something we had never done before. A good example would be we do freight out of a place right down near the border, near Windsor, and that city obviously has activity, and it's within this cluster on the right-hand side here. That city has activity that comes out of it. But if a customer were to come to us and say, well, I ship out of here, happens to land in that cluster, we'd have to be able to create a valid proxy rate to allow the pricing engine to price something that we'd never done before. And so establishing an anchor for that cluster allowed us to be able to take those thousands of potential origin and destination combinations, well, hundreds for sure in this image that you're looking at, take those hundreds down to very few. And in fact, our target would be to have less than 40 of them potential, and the anchor itself in this particular case basically gives you 2. You have an anchor origin, say in Ontario, and an anchor destination in Chicago, or an anchor out of Chicago into this area in Southern Ontario, and basically it allows the pricing engine to function in that simple environment. Once we had those anchors, we had to be able to say to ourselves, how can the network model inform how the price should be created based on the fact that that new order that we might price is going to fall into a network of existing orders that would be handled in various ways. And so once we established those clusters and the anchors, we also established an edge relationship between those nodes, which would be the cluster anchors, that said, here's what typically happens when an order goes from here to there. The bottom line in that first view is that we took that network model and we used the network view with subnetwork vision, and we were able to improve margins as a result. We were able to take these cluster relationships and anchor relationships, overlay them into the network model and say, here's how a trip would typically flow. And once we were able to establish that flow, even though we had never done a particular origin and destination combination before, we were able to move to create a rate for something that would be sensitive to the network in which that order would land. Yeah, I said it earlier in the end, because of the fact that we had this resilient network model that was able to help us understand segment of order to order, and be able to aggregate in any way we want to, for customer, for origin and destination combination, for region, for division, for particular types of driver, particular types of equipment. And not only were we are able to have a whole network view, but break down to sub-networks as I've described, we found ourselves able to create improved margins by not only measuring the profit and being able to act on those measurements, but also to be able to use it to fuel the pricing engine. So I guess I'll pause now to see if there are any questions. That would be the end of, I'll say, what my formal presentation is. If we have a little time, I want to maybe describe the node and edge relationships a little bit that I've mentioned earlier, but open to questions now. Okay, hearing no questions, I'm just going to take a minute and talk a little bit about, oh, great. Okay, fantastic, Andrew, thank you. Let me just take a couple of minutes here and go through at least one slide on node and edge relationships. This is getting a little technical, but I think some of you who are into data science would find this interesting. So we've got a graph database, and as I said earlier on, the nodes are the centroids or the anchors. Yeah, Catherine, thanks for your question. We could not hear you if you were speaking there. And so, Catherine, if you want to, if I, for instance, stop sharing, perhaps.
I was talking in that silence, and I thought you were listening to me. Okay, so since everybody can hear me now anyway, so I'm going to ask. You had that picture with the solid lines, and you said green or whatever was pickup, and one was delivery.
Yeah.
But could one of those paths be a driver picking up something on the way? And could the model accommodate like splitting the costs or whatever, you know?
Yep. And so that would be an example would be we haul very sensitive food products to retail stores, like a Loblaw store, for instance. And sometimes those sensitive food products, they put all their sensitive food products on one trailer, and a little bit of each trailer gets delivered to 4 or 5 or 6 different stores. So that would be an example of that.
Okay.
And then sometimes when we haul that sensitive freight, we might pick up at 2 or 3 different places and load that way. So yes, some of those legs could potentially be multiple pickups or deliveries along the way. Yeah.
Okay. Thanks.
And the system will accommodate that. It understands when an order has multiple stops on it. It understands what that means, and it's able to accommodate, even if, for instance, the data is not accurate within those stops. It's got a default matrix that allows it to cost out, even if the data that it's looking at isn't perfect. It can cost out or revenue out a trip, even without perfect data.
Okay, got it. I don't think there's any other questions right now.
Okay. So, Catherine, should I just take a couple minutes and talk about
Sure.
paths? Okay, so I'm just going to share again quickly, so I'm going to lose you probably. So we've established the centroid relationships, and we've established the edge relationships. Here in this example, there are 3 different types of edge. A segment, which is what I've said earlier, just one part of an order. A path, and that path is essentially the geographic distance between one place and another. So it's really not necessarily a part of our network. It is just a geographic representation of, say, the distance between one place and another. That's the path. And then the round trip move is another edge that represents the fact that in this particular middle example, that we've got an order that starts in Calgary and it stops in a place called Sicamous, BC, which is halfway between. This is just an example, by the way, and it ends in Langley, and that a particular group of orders, in this particular case, it's probably 2 orders, one from Calgary to Vancouver and one from Vancouver back to Calgary, are parts of a round trip that occurred. So any one order from Calgary to Vancouver would have order segments that might be independent. I'll give you an example of order segments. So let's say, Catherine, you were the driver on the highway and I was the driver in the city. My segment would be, I'll go to the customer with an empty trailer, I'll load the load, and I'll bring it back to our trailer yard. And Catherine, your segment might be to pick it up and take it on the highway. So that's an example of a segment. If you took it on the highway and drove all the way to Vancouver and then picked up another order and came back, that would be your round trip. So the round trip move is made up of segments, and the path to that move is essentially just the geographic distance between those places. And so we, inherently, and you can see why, inherently in any measurement, especially like our business is all about geography, in any measurement, we have to know the distance between places. We have to know the relationship between orders that caused the subnetwork to function, and then we have to be able to break it down to its segments so we can understand. Just going to read this question that came up. What granularity do you keep for segments? A, origin and destination per hour and per, yeah, so really good question. When I talked about the city segments, those are generally kept per hour, although there are some exceptions to that, because very large cities like Toronto, you have to have a variety of different ways to cost a segment. And then generally on the longer moves that would be on the highway, those are kept per kilometer or per mile. Those segment costs are represented that way. The actual relationship is quite more complex than that, but it's said simply, that granularity is arrived at there. And you know what? I'm answering these questions in the reverse order. So that the segments by origin and destination are kept as well, because that allows us to be able to aggregate up to order level or aggregate up to origin destination combination level. I'll give you an example. We have lots of freight that comes out of the US and flows through Winnipeg and goes to Vancouver. And then in between Winnipeg and Calgary, we have an operation where one truck pulls 2 trailers, because that's allowed on the prairies, allowed for one tractor to pull 2 trailers. So for a period of time in the US, that one truck is pulling one trailer up to Winnipeg, say, and then in Winnipeg, that one trailer that comes into Winnipeg gets matched up with another trailer and goes to Calgary. And then in Calgary, they get split up again, and 2 trucks pull those 2 independent orders from Calgary to Vancouver. So that's an answer to the origin and destination, and why segment origin and destination and order origin and destination are different from each other, and also independently very important. Andrew, thanks for sharing that question. We've got a couple more slides here that I could go through, but I see that we're quite a bit over the time I promised. And so I guess what I'll do is maybe just go into what we plan on doing next with these 2 very important models that are inherently related to each other. We are moving to machine learning, and I think I referenced it a little bit earlier on. We've got some automated processes that help the pricing engine price quicker. And also, since the day we started with Pricing Engine 1, we've been saving, when we call the pricing engine and get a price, we've been saving that price, and we've been comparing it to the price that we. So since day 1, we've been saving all that data, understanding that provides a backgrounding, like it provides a training database for machine learning processes. Today, we are in the very early stages of considering how we might apply machine learning to the pricing engine, and very thankful that we're actually going to be we're partnering with a variety of organizations, and one of them could be the U of M in being able to I'll say learn more about that, but with the intention of executing on that. These 2 other things that are also very important. Like I get excited when I talk about machine learning, because it's a new frontier, something cool to do that we haven't done before. But we also have established out of the network model corporate targets to say this subnetwork or this whole network needs to deliver a certain profitability. And because of the way we can get right down to segment level or whole network level, we're able to translate those corporate targets to any granularity that we need. And in addition to that, we've infused all this information to all of our tools. And so when a person who's handling drivers talks to a driver about a particular customer's order, the operating ratio of that order is present in the picture. And so they can understand how this particular order contributes to profitability or not within the network. And not every person that sees that information uses it actively every day, but it's sort of like, if that information is always in the background, inherently we're always focused on profitability. And if you refer back to all the way to the start of my presentation, our margins are so narrow, everyone has to be concerned about profitability in our business. Well, I want to say thank you to everyone that joined us today. If there are more questions, I'd like to field them right now, but I'm happy to field questions, or if that's it, then that's all for today.
Thank you, Dave. I think that everybody asked all their questions, so I think I just have to thank you. It was very interesting. Thank you for accepting my invitation. It was a pleasure listening to you today. Thanks, everybody, for coming. Thank you. Take care.
Stay safe, everybody.